Alright, we're going to go ahead and continue with 8.8a, but now we're going to look at the electromagnetic spectrum. Alright, so let's just start from the largest and least harmful radio waves to the most harmful. So the largest radio waves, and then remember it'll start getting closer. God, I'm not good at those. And closer, and closer, and closer, and closer, whatever. Something like that. But the largest radio waves and the least harmful are radio. And we'll continue on down, then we go get to microwave. Then something that's a little bit more harmful, but because of its frequency or its closeness, is going to be infrared. And then we get to visible light. And then past visible light we get to ultraviolet or UV light. Then a little bit more harmful are the X-rays. And then the gamma waves. So this is the electromagnetic spectrum drawn to the best of my abilities. Of course, these are really, really, really tiny, whatever. So remember, this is energy that stars emit, or given off or emitted by stars. All stars, even our sun. Okay, and here's the least harmful to us and all animals, and here's the most harmful. There's only one form of energy we can see, and the only part of this whole energy spectrum we can see is the visible light. That's it. You cannot see UV light, you cannot see infrared. We can only see visible light. And remember, we said visible light was made up of, the visible light we see is made up of all the rainbow colors of Roy G. Biv. Y'all remember that? Alright, so that's all we see. Infrared is heat. We feel that. And UV gives us a sunburn, but we don't feel it until we're burnt. So, really from this point on, it's very harmful to humans or any other animal, all animals pretty much. Alright, so looking at how does that relate to the length of the wave, or how often the wave is moving, or how quick many are in a certain segment. Well, here we have large wavelengths. A wavelength is this distance, okay? So they're large here, but over here we can't even see them. And here we have small wavelengths. So the smaller the wavelength, the more harmful the wave. If we measured what we call frequency, meaning how many waves pass in a certain minute, well, they have large wavelengths, so they're going to be slower. This is a low frequency. And over here, the small, harmful ones have a high frequency, meaning a lot of waves can pass in a second. Here, only a few waves may pass by second, but here you might have 1,000 waves per second. Energy is measured in a unit called hertz. And I know on the sim test, you guys there was a question that related to actually looking at another star, and let me find that question if I can. Hang on just a second. That electromagnetic spectrum thing. Where is it? Well, now I'm having trouble finding it. Oh, here it is. Okay, so if we look at that, what I want you to see is that they're giving you here the wavelength. So how much distance is from here to here. Remember the longer ones. Here's the long ones, and here's the short ones. Shortest and longest. Alright. And they're giving you numbers to go with it in meters. And then, or with exponents even. So here's the largest, the smaller, 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 to the very smallest. Alright, and here they're using frequency. So they're giving you the frequency, or how often the waves pass, in the unit hertz. Okay? Here it gave you a frequency of a certain amount of hertz. This is really good because it actually just told you, look there. Remember, and we already went through this, and see if you can figure out what they needed to use to locate this body in space. Well, we know that all different forms of rays can be used to locate objects in space. You just need to pay attention to these small details when you're reading these. That will help you the best. So I hope that kind of reminded you of what we have as far as the electromagnetic spectrum and how to read it.